Welcome back to Low Stress Math with Mrs. Bono. We are still in Unit 3, Lesson 12, More. How many solutions to the equation? So, that's what we're doing. We're going to determine how many solutions there are to an equation. All right, we're going to determine the number of solutions. So determine if the value x equal 2 is the solution to the equation below. All right, the way you do that is you're going to substitute 2 where the x is. So let's try that. 3 parentheses, make sure people can see what you're doing, and where the x is 2, there we go, minus 4 equals 4, and wherever there's an x, so there's more than one x, we have to fill in more than one 2 in parentheses. 2 plus 7 minus 2, and again, one more x, I got to put it there. So, order of operations, parentheses first. 2 minus 4. Well, let's see. 2 minus 4 is negative 2. So this side says 3 times negative 2. And nothing else changed because that was the only parenthesis. 4 times 2 plus 7 minus 2 times, I wrote x here. See, that's me being all silly. Times 2. And now I have to fix that because that doesn't look very professional. There's supposed to be a 2 in that parenthesis. All right, now, parentheses, exponents, no exponents. Multiply, I can multiply. 3 times negative 2, negative 6. 4 times 2, 8. Plus 7, negative 2 times 2, minus 4. All right, now I just have to do the adding and subtraction. So nothing happens to negative 6. 8 plus 7 is 15, minus 4 is 11. Wait a second. That's not true. That is false. That is untrue. So 2 is not a solution. X equals 2 is not a solution. But it makes me want to know what is the solution. So I'm actually going to quickly solve this problem because I want to know what the solution is. Now that I know 2 is not the solution, I'm going to find the solution. So let's do this. 3 times x, 3x. 3 times minus 4, minus 12 equals, then that just stays the same. 4x plus 7 minus 2. All right, so now I have to combine like terms. And I have to, oh, I forgot an x. Here we go. Now my like terms changed. 4x minus 2x is 2x. So now I have 2x minus 12 equals 4x minus 2x plus 7. Let's see. And oh my gosh, I'm just going to stop the video. No, I'm not. I'm going to fix my mistakes because you know what? Everybody makes mistakes and you just have to fix them. It's okay to make mistakes as long as you realize you make a mistake and you fix it. So 3x minus 12, fine, that side stayed the same. 4x minus 2x, that's 2x. So 3x minus 12 equals 2x plus 7. Now, to go over the equal sign, you have to do the inverse. So I'm going to subtract 2x from both sides. And I get x minus 12 equals 7. Because this was 0. All right, now I have to add 12 to both sides. And realize I've run out of room because, well, me. And I end up with x equals 7 plus 12, 19. So you know what? There's only one solution to this problem. There's one unique solution. We'll talk more about this later. So for this problem, there was one unique solution. And you could try any number you want. I made you try x equals 2, but you could put any number in there. And unless it was 19, it wasn't going to work, because 19 is the only unique solution for this equation. Let's try the next one. Solve the equation for the variable. Okay, I know how to do that. Let's try this one. All right. To get over the equal sign, you have to do the opposite. And what's the opposite of x? Minus x. So I'm going to subtract x from both sides. Well, let's see. X minus x is 0. Bring down negative 2. X minus x is 0. Bring down 7. Well, that's not true either. This is not true. What do you call it when it's untrue? When it's not true? Untrue. False. This is false. This is untrue. I.e. false. It's a false equation because it's not equal. It's unequal. All right, let's try this one. So we have to do the distribution first. 3 times x and 3 times negative 3. So you start with distribution. 3x minus 8 equals 3 times x, 3x. 3 times 3 minus 9 minus 2. Okay, keep change. I don't like all the negativity there. So I'm going to change it, if I don't drop my pen, to plus a negative sign. Remember, minus is the same as plus a negative. So I'm going to add a negative. And stop falling. Here we go. Now I can combine like terms. Negative 9 plus negative 2 is negative 11. 3x minus 8 equals 3x minus 11. Oh dear, I think it's going to happen again. If I subtract the variable, I'm going to have negative 8 equals negative 11. Well, I'm going to do that. Here we go. Subtract the variable. Negative 3x, negative 3x. And now I have another false equation. Negative 8 is not equal to negative 11. None of these are equal. It's all unequal. Bad. Not equal. This is also a false equation. The variables cancel each other out. Oh, right like down here. The variables cancel. And what's left is not equal. The variables cancel, and what's left is not equal. And that's what you would call a false equation. Because equation means equal. And if it's not equal, well, then that's a false equation. It's unequal. So if we cannot find a solution to the equation, meaning our variables cancel each other out, and there's a false equation, we haven't made a mistake. The equation has no solutions. So this has no solutions. And I'm going to highlight some stuff because it's important. And I already wrote it in bold, I know, but I just wanted to jump out of the page when I'm studying for my test. Variables cancel each other out, and a false equation is what remains. A go. So let's take a look on the next page, see what's happening. Oh, it did not turn. Come on, paper, thank you. Here we go. All right, example 2. A little bit of distribution to start. So 4 times x and 4 times negative 2. 4 times x is 4x minus 4 times 2 is 8 equals 5x. And I'm going to move this negative x next to the 5x minus 1x minus 7. Because I like to combine my like terms when they're next to each other. So 4x minus 8 equals 5 minus 1, 4x, again, minus 7. Now let's take a look at this. What do they have that's the same? Yeah, that's the same variable, and they also have the same coefficient. That's the number next to the variable. So I'm going to start with that. They have the same coefficient, and that's 4. And they have the same variable, and that's x, but they have different constants. Because on this side it's negative 8, and on this side it's negative 7. So I have negative 8 and negative 7. Because they have different constants and the same coefficient and the same variable, that means no solutions. All right, let's take a look at the next one. See if that's doing the same thing. Now, you know, I'm going to put my variables next to each other. So what do I have here? 5x plus 3x. And I'm going to leave this minus 2 alone, equals, 3 times x, 3x, 3 times 4 plus 12. Oh, wow, there's a lot going on here. Plus 5x minus 14. Oh my goodness gracious, there are a lot of like terms on that side. Well, let's take care of this side first. 5x plus 3x is 8x minus 2. Now let's look on this side. On this side I have, what have I got? A pink pen, that's what I have. I have 3x and I have 5x, and together 3x plus 5x is 8x. And what else have I got here? 12 minus 14 plus 12 minus 14. Well, let's see. 12 minus 14, that's negative 2. Look at that. That looks familiar. That looks familiar because it's way back here on this page. Remember? We had the same constant, the same coefficient, the same variable. That meant infinitely many solutions. Well, that seems to be happening again. Ha-ha. Same coefficient. And that's 8. Same variable. And that's x. And it also has the same constants. -2, and -2. So what does that mean? That means infinitely many solutions. All right, now there's a you try it. That means turn off the video and try the problems yourself. You need to try math to do math. It's just 2 problems. You can do it. Tell whether each equation has one unique solution or infinite solution, and show how you arrive at your answer. So, you know it's either gonna have one unique solution or infinite solutions. And how do you know? Well, I hope you tried the problems, because you know the only way to learn math is to do math. So let's start with this side. 5 times x is 5x. 5 times -2, -10. And equals, I'm going to put the 4x and the 1x together. 4x plus 1x minus 10. 5x minus 10 equals 4 plus 1, 5x minus 10. Ha! Look at that. They're exactly the same. They have the same coefficient. And that's 5. They have the same variable. And that's x. And they have the same constant. And that's -10. When everything is the same like that, that means infinitely many solutions. I'm going to write that in blue because I like blue. Infinitely many solutions. So when it's all the same, it's infinitely many solutions. But up here, if you have the same coefficient and the same variable and different constants, that meant no solutions. Just be careful. You don't want to mess up that kind of thing. All right, now, just a little divider so I don't make messy math. I'm just going to put a line over here, like I did up top, but I didn't do down here because lazy. I don't know. I messed up when I was doing this paper. Here we go. Now, that looks very confusing, but you can do this one step at a time. Just go slow. You can do it. Here we go. -3 times x, -3x. -3, grab that minus sign. -3 times -4, +12 plus 2. Oops, that plus 2 should not be written in black. It should be written in black. Plus 2 equals, I'm doing some more distribution. 2 times x, 2x, 2 minus 5 minus 10 plus 3x. Now combine like terms. On this side of the equal sign, the -3x is alone. But 12 plus 2 is 14 equals, on this side, 2x plus 3x, 5x, keep the -10. Look at that. Now I have different coefficients. When you have different coefficients, that means there is one unique solution. So let's write that down. Different coefficients. It also happens to have different constants. The only thing it really has the same is the variable. I'm not even going to write that down, though, because I don't have to solve this problem. It didn't say solve for x. It says, tell which equation has one unique solution. Well, if it has a different coefficient and different constants, then that is one unique solution. So, I don't even have to solve that problem. I know, one unique solution. All right, let's come down here. What do you notice about the variable terms in all of the equations with no solutions? Well, let's look up here. This is our equation with no solution. The coefficient and the variable are the same. So let's write that down. The variable term, the coefficient, and the variable are the same. On both sides of the equal sign. So, the coefficient and the variable are the same on both sides of the equal sign. What do you notice about the constant terms? The constant terms are different on the constant terms are different. So, what do I notice about the variable terms in all of the equations with no solution? So the variable terms are the same when there's no solution, but the constant terms are different. Okay, not a bad day. Enjoy yourselves, relax a little, and I'll talk to you later. Bye.